Hello, my name is Levitsky, and I'm excited to share with you what I've been working on for the past 2 months. Welcome to my Capstone project, the Zion Rescue Stretcher. So, before I show you my designs and solutions, I'm going to give you a little bit about me. We're going to talk about some of the research I did, which helped to influence the design brief. With that brief, I was able to develop my process and solution. Then I'm going to give you guys a quick recap of everything that I told you. So, who am I? As I said, my name is Ski. I am an outdoor hobbyist. One of my favorite spots to hike and climb is Red River Gorge in Kentucky. As I said, I enjoy hiking and backpacking. My dad and I have been going out for probably 12 years now, and I love climbing and rappelling. I've been climbing for 5 years. I'm proficient with multiple pieces of climbing equipment and methods. My experiences have given me a perspective for my project, and I understand what it's like to operate under stress. So, why did I want to design a rescue stretcher? I wanted to design a rescue stretcher because it pairs my passion of the outdoors and climbing with an important industry that saves climbers and hikers in the event of an accident. If I'm ever climbing and I take a big fall or I get injured, I want the rescue providers to have the best equipment and to be set up and prepared the best so that I can get the treatment that I need. I'm able to use my experiences through empathetic design to help people. So, what is high angle rope rescue? Put simply, high angle rope rescue is any rescue operation involving cliffs or elevated areas where a rescuer cannot operate safely without the use of ropes and anchor systems. Come with me and let's observe what a typical rescue process can look like. Meet Ben. Ben loves hiking just like me. He starts off on his hike in Red River Gorge. His backpack is loaded with snacks and water, and he even brought a hammock in case he wants to take a break. A couple miles into his hike, Ben sees a cliff with a beautiful scenic vista. He takes a short detour off the trail to take in the views. While walking to the edge, Ben trips on a loose rock, sending him tumbling 50 feet off the rocky cliff to the ground below. Some nearby hikers observe the scene and quickly call the local rescue team. The team loads into their vehicle and they race to the trailhead. Upon arrival, they begin the 2-mile hike to the scene of the accident. When they make it, the team begins preparations while a rescuer rappels down to render aid. At the bottom, the rescuer begins to stabilize Ben. After Ben is stabilized, he is loaded into a rescue stretcher and the ascent up the cliff begins. About halfway to the top, the rescuer needs to change the orientation of the basket to avoid a large tree branch, but he finds it difficult to do so because there isn't any leverage. To make do, he has to throw his leg over Ben, risking further injury. Now at the top, additional rescuers pick up the basket and begin the 2-mile hike to the ambulance. Along the way, they have to make frequent stops to rest their hands and change positions, costing them precious time and depleting their energy along the way. Despite the difficulties, the team makes it and is able to deliver Ben to a hospital where he will receive further life-saving care. While Ben was able to hang on in light of the additional time, not all patients have the same fortune. So how can I improve the process that I just showed you guys? Well, first off, during the ropes phase, it is necessary to redesign the stretcher to make changing the orientation more intuitive and adding more locations for rescuers to grab a hold of the stretcher. Secondly, during the transport phase, rescuers need a piece of equipment to assume a majority of the load so they can save time and energy. So, to help me solve some of the problems that I just discovered, I had two really awesome contacts within the industry. The first being Micah. He is a product development engineer at Vertical Supply Group and a former ICC student. Throughout the process, I was sending him my designs and he was giving me feedback and critiques. He helped me to think about things from a manufacturing perspective and think about what customers are actually going to want to buy. He was an awesome help. He even sent me a care package with a nice bag, tons of rope, dynamic line and static line, some climbing gear, and just sent me a bunch of freebies just so I could test out some of the equipment that rescue providers would use. I got to feel a typical backpack and see what the weight would feel like, and it was really nice to get to use him as a resource. Second is Dalen Zartman, who's the president and founder of Rescue Methods. Dalen is a career firefighter rescue specialist, and he's the leading voice on rope rescue. Whenever I was looking at YouTube videos trying to find some information about rope rescue, oftentimes Dalen was the one narrating these videos. Mr. Zartman offered me an opportunity to observe and participate in a rescue training course through the Washington Township Fire Department. This valuable experience gave me insights and increased my excitement for the process. So, in just a moment, I'm going to show you a short video of my day. Pay close attention to the difficulties I face when I'm trying to change the stretcher's orientation. You'll see this about halfway into the video.
Buddy.
Backwards. Right.
Buddy.
So it was a really fun experience. I enjoyed getting to hang out with a lot of firefighters. I got to observe and listen to them do their rescue training. I got to see their pain points, see the things that they enjoyed, see the things that they wanted to change, and really get to know who I was designing for. Um, like I said, it was difficult to change the basket's orientation. You can see this being displayed in the upper right-hand corner. I had to throw my leg over a patient, and if they have a lower leg injury, that could further injure them or cause them discomfort, which is uh, definitely something I want to avoid with this project. I really enjoyed Mr. Zartman and getting to know him. He was extremely accommodating, and he took time to make sure I understood the process and talked to me one-on-one. He explained everything in real layman's terms, and was just a great help. I'm really blessed to have been able to get hands-on experience directly related to my project. Instead of watching from afar, I got to actually experience the problems firsthand, which gave me a personal investment in the much-needed solutions. Further insights from this research and training was that it was difficult to change the basket orientation, as I've been saying. Second is that the rescue gear is pushed to its limit. So the basket is getting banged against the wall as we're going up and down. It's getting dropped, gear is placed in it, it's hitting branches, it's getting scraped up, and it's under a lot of tension whenever there's a patient in the basket. Third, rescuers have to haul the victim for miles. So in my mind, I was thinking that the rescue providers would just be able to drive right up to the scene of an accident. But in some cases, they have to hike as far as 2 miles into a scene of an accident and then hike back with all of their gear and a victim that they're rescuing. So gear needs to be lightweight, needs to be durable. So as I just said, rescue services need tough, lightweight gear that works with them. So after researching and participating in the rescue class, I developed a design brief that would help guide my process and keep me pointed in the right direction. My brief was to design a lightweight stretcher and accompanying transport for the year 2040 that enables rescuers to intuitively use the stretcher and save energy. Some goals that I have for this project are to model with Gravity Sketch, which is a virtual reality software that allows you to model in 3D. You can scale your models up to life-size scale at 100% and see those how they would be in real life. You can kind of overlay that onto whatever you're seeing, whether that be a classroom or outside, and it just gives you a better perspective. Second, I want to practice empathetic design. I want to design for what the users need, not what I want to give them. And finally, I'd like to explore alternate solutions. I want to look outside of traditional solutions within the rescue sphere and borrow technology from other industries. So before I get into my designs and sketches, we need to look at what some of the competition is. So the first off is the Furno stretcher. This is the one I got to use in the rescue training. It's plastic, it's 31 pounds, and the draw to this stretcher is that it's affordable. Because it's plastic, it didn't feel the most durable, didn't convey to me a sense of strength. The plastic felt plasticky and cheap. And I think that this could be redesigned to be a little bit less bare bones and feel more durable and convey a sense of strength. Second is the Junkin stretcher. It's made of plastic and aluminum. It is also 31 pounds. And the draw to this stretcher is that it's foldable. So it packs down really small, it's easier to carry. But with that foldability, if it's not joined together correctly, there could be issues with structural integrity. And then finally, we have the CMC stainless steel stretcher. As the name suggests, it is stainless steel. It's also 31 pounds. And this is the most innovative stretcher on the market right now. And I took a lot of inspiration from this stretcher. One of the things I like is that the exterior frame allows rescuers to grab onto the side. Additionally, the inner mesh is replaceable, which extends the life of the product, saving the fire department money. Now we're going to get into ideation and modeling that I did for this project. So here are my sketches. I really enjoy sketching process. It's really fun. It helps me to really get a lot of ideas out really quickly. You can see I started in the bottom left-hand corner, looking at different transport options, thinking about other ways to make stretchers innovative and redesign, and I ultimately finished in the upper right-hand corner with the highlighted stretcher. So during my ideation, I learned about the emotion that shapes convey. For example, circles convey a feeling of softness and relaxation. The rescue stretcher needs to convey a feeling of strength and toughness, so I chose to use squares and triangles which evoke these emotions. In the design, you can see that what I'm going to call a triangular rectangle is all folding and pointing into the center of the stretcher, which is demonstrating its redundant structure and building a confidence in the product. After I found my final concept, I took it and sketched in perspective so I could visualize it in 3D. On the right, I played around with making the design solid, like the Furno stretcher, but I ultimately moved away from this to align more with the lightweight aspect of my design brief. After sketching, I was able to move into my favorite phase of the project, which was the modeling phase. I chose to use VR like my goal for the project. And so I was able to picture it in 3D and interact with it a lot better throughout the design process. My first model on the top in orange was created directly from my sketches, and I realized that it lacked the correct proportions. So my next model on the bottom in green focused on fitting to the contour of the human body. In the picture on the right, you can see that I also 3D printed my stretcher, and that helped me to really see it in 3D and put it in front of me as I was working on the project to keep my excitement going. Additional ideation included extra handles, but I found that they added unnecessary weight, and the outer frame already offered ample grip points, so I moved away from this. To solve the problem of changing the stretcher's orientation, I ideated on a foot plant strategically located at the foot of the stretcher. My first three designs were too angular, and problems arose with rescuers potentially getting their gear stuck on the piece of metal jutting out from the side. My final design in the bottom right opted for a more gradual angle, and it fit tighter to the frame, making it a little bit more low profile. So, after multiple rounds of ideation, sketching, and modeling, I had a final model that I was able to export to Keyshot to begin to add materials. This part of the process really brought the structure to life. With that, I'd like to present to you my final concept, which I'm super excited about: the Zion Rescue Stretcher. The Zion is lightweight and solves the problems I identified throughout my research. The stretcher is tapered to fit the human body, which cuts back on weight and material. You can see it takes on a coffin shape, although I really hope a victim doesn't end up in one. Low profile footplants are located on the left side of the stretcher. Made of 775 T6 aluminum, the frame is extremely durable while weighing 25% less than the competitors, setting at about 23 pounds. An elevated 1-inch top rail puts space between the victim and the rescuer, ensuring they aren't further injured, while offering the perfect size grip for prolonged use. A replaceable steel mesh interior allows rescuers to save money and extend the life of the stretcher. Strategic lashing points positioned throughout the stretcher ensure the patient will be safe and secure no matter the orientation. A bright colored foot catch allows rescuers to quickly identify where they need to place their feet and get the proper leverage they need. The Zion's three-part construction offers redundant strength, conveying durability and building a confidence in the product, ensuring the stretcher will do its job for years. So think back with me to Ben's story from the beginning of the presentation. The process had many problems that I aimed to solve. Now that I've redesigned the stretcher, let's go through the story again, this time with the Zion Rescue Stretcher. The rescuer loads Ben into the Zion. He is able to secure Ben to the stretcher using the multiple intuitive lashing points. The rescuer begins the ascent up the cliff, but this time he is able to quickly identify where the foot plant is and naturally change the stretcher's orientation using the foot plant in the exterior frame as leverage. The rescuer can determine what foot position is most natural, whether that be resting his heel or using his toes for leverage. The rescuer doesn't have to awkwardly throw his leg over Ben, but can instead focus his attention on performing the rescue. Micah Hensler says he could see this project being something that Vertical Supply works on in the next 3 to 5 years. But what about a solution for 2040 like my brief states? I would like to introduce to you guys phase 2 of my project, where I utilize Boston Dynamics futuristic technology. Meet Spot. Spot is an intelligent robotic dog first introduced in 2016 who's being implemented into multiple industries. Some of those industries include construction, manufacturing, energy and resources, education, and the scariest of all, government. I don't know what they're going to be doing with Spot, but I don't like it. I'm also proposing that we add search and rescue to the list of industries that Spot's technology can influence. Rescuers need an intelligent transport that can quickly navigate rough terrain and save their muscles from fatigue. The Zion Rescue Stretcher is mounted by a proprietary mounting system I designed specifically for this project. The S-Lock mounting system features a durable stainless steel body, ensuring it won't bend or break under various loads. A tapered design allows rescuers with gloved hands to quickly turn the high visibility adjustment knobs. Picatinny rail mounts with position locking screws ensure the S-Lock system can be quickly assembled while providing maximum strength. The S-Lock system works pretty simply. It works by threading the two pill-shaped attachment points through the housing which would be connected to the stretcher. Once in place, rescuers return the spring-loaded adjustment knobs underneath, snapping them into place and allowing the rescuers to bind the Zion to Spot's back. So let's think back to Ben's story one final time. After ascending the cliff, rescue personnel fix Ben in the stretcher to Spot's back with the S-lock, ensuring he won't fall off. The S-lock sets the stretcher about waist high, allowing the rescuers to comfortably transport Ben to the ambulance, preserving their energy and saving their backs from fatigue. The transport process is expedited with the use of Spot, and Ben has a higher chance of quickly getting the life-saving medical attention he needs. Because Spot assumes a majority of the load and is intelligent, he can navigate the rough, rocky terrain far easier than 5 guys holding a stretcher could. Now that I've demonstrated my innovations in the rescue process, I'm going to do a quick recap of the project for you guys. So as you know, rescue personnel need tough, lightweight gear that's going to work with them. My brief was to design a lightweight rescue stretcher and accompanying transport for the year 2040 that enables rescuers to intuitively use the stretcher and save energy, which I accomplished through the use of Zion and the Spot transport. The goals that I had for this project were to model with Gravity Sketch, which I accomplished through my stretcher. Second, I wanted to practice empathetic design, which I did through taking a day and putting myself in the user's shoes. And finally, I wanted to explore alternate solutions outside of the rescue industry, which I achieved through using Spot as a transport. I want to say thank you to the professors and professional contacts, classmates, and my family for just encouraging me throughout this process. A lot of people gave me critique and feedback and great advice throughout the project that really helped it to be what it is today. Your support has meant so much to me, and it's really kept me going and got me where I am. So thank you so much. With that, that's the end of my project. Thank you for sticking around and watching. I really appreciate it. Have a good one.